It is my pleasure to introduce Mr. Bob Zolo from Agilent Technologies, who's a product planner for the N6705A DC power analyzer. This is a totally new product that was introduced a while ago, but there's nothing else like it in the market. I found it very interesting, and so it's my pleasure to introduce Bob. Bob, what can you tell us about the Agilent N6705 analyzer?
Well, the DC power analyzer is a quite unique product in the marketplace. Its focus in life is to be a productivity tool for the R&D engineer, such that they can get their job done much more quickly by avoiding programming and being able to interact with an instrument in a more natural way.
This instrument, you say for R&D, but the basis of this instrument had been around for a while. It's got proven technology in it, right?
Exactly. The predecessor to the DC power analyzer is a product called the modular power system from Agilent Technologies. That's the N6700 family. And that product is focused on ATE applications. It's one rack unit wide, one rack unit tall, and has 4 slots for up to 4 power modules, so hence it's a modular system. But that product was focused on the ATE market by its form factor. So we wanted to serve the R&D market as well. So the way we went about doing that was by taking the technology that was in the modular power system and transforming it into an R&D tool, hence the development of the DC power analyzer.
So what was your analysis that an R&D market needed it? What gave it the green light at Agilent?
Great question. So obviously, in today's modern world, there's increasing pressure on R&D engineers to do more with less. R&D cycles becoming shorter and shorter. When I started in the electronics industry 25 years ago, having a 5-year development cycle on a product was pretty common. But now you'll see new cell phones coming out every 6 months, very short design cycles on many products. So as a result, the R&D engineers really need to sort of step up and go faster. So a tool that can help speed up the R&D process is something that the industry was looking for, and particularly with respect to power, where the challenges of doing power-related measurements and power-related tasks can be quite cumbersome.
So what are the kind of measurements that you can make with this instrument?
Well, the instrument combines the technology of several different instruments into one package. So in this one box, you've got up to 4 different power supplies, a voltmeter, ammeter, data logger, oscilloscope, and arbitrary waveform generator. And by bringing all those pieces together, there's a number of tasks you can do with this integrated instrument that would be very difficult to do with a collection of standard instruments. So for example, you can create startup sequences, turn on and turn off sequences with very precise timing between them. This is important for many applications today where you could have a latch-up occur if your sources came on in the wrong order. You can visualize what's actually going on as you turn those out sources on and off, because you have a display on the instrument that can display the information the same way an oscilloscope would. So you could look at things like voltage versus time, current versus time, or power versus time. Because of the built-in arbitrary waveform generator, you can create transients and look at things like what happens to my device if my voltage were to suddenly drop off or come back on again when I'm powering it up. So you can look at the response to transients, you can look at things like inrush and turn-on sequences, and with the data logger, you can log power consumption over either very short periods of time or very long periods of time for looking at things like battery rundown, for example, on a battery-powered device.
So in the past, an engineer would have to go to the production department to get his automatic test equipment system. He'd have to grab a bench power supply. He'd have to grab a meter and an oscilloscope, all these different pieces. But your product, the N6705A, combines all of that into one. So a much smaller footprint on the desk and on the workbench. And I guess also, do you have a means of quickly recalling setups and things like that so that frequently used setups are easily recalled?
Absolutely. There is a non-volatile memory in the instrument that can store test setups as well as test data. You could also store those setups on a front panel USB memory stick so that you could approach an instrument with your own little personal setups and then plug them in. Because, you know, shared resources always end up getting reconfigured and put back into a different configuration. But to the first part of your question about about collecting the instruments together, that's actually only part of the problem, right? I mean, most engineers have these instruments on their bench already. Where the challenge comes in is actually making them work together harmoniously. So, for example, if you did want to measure the current that's coming out of your power supply on an oscilloscope, well, what are you going to have to do? You're going to need some transducer to be able to look at that current. You're going to need a scope probe or a current shunt or a current probe, something like that. And we found that a lot of engineers are like, well, I know there's one floating around, but Joe borrowed mine or Mary's got it on her desk. And you end up having to rummage around to find these pieces. Now, once you finally put all the pieces together, then you actually have to configure the measurement to be made. You have to set up all the different pieces to actually make the measurement. And finally, does the engineer really understand the measurement accuracy that they're going to be getting out of this configuration? Because it's a bunch of different instruments with various transducers, to understand the real measurement, how good the measurement will be, is quite difficult. With an instrument like ours, because it's a single box solution, all those specifications are given already. You can just open up the data sheet and know the exact accuracy at which you'll be able to make a current measurement. You know the exact rise time that you're going to get on the power supply. You'll be able to know the bandwidth you'll be able to get on the arbitrary waveform generator.
I see. And so my understanding is that you've won several awards for this, and I suspect that you might have some other products coming down the line that are related to it. Any comments on that?
Well, I will comment first on the awards. Yes, we're very, very proud of the DC Power Analyzer. This product is the most awarded product in Agilent history, which is about 10 years. But if we go back even further, in HP's history as well, putting another 60 years in front of that. So we've won 7 different industry awards, things like Test and Measurement World's Test Product of the Year, EE Times Annual Creativity and Electronics Award, the IEC's Design Vision Award, Design News Golden Mousetrap Award, Electronic Products Product of the Year. So these are very prestigious awards given by the industry for recognition of the innovation of this product.
That's great. It's a very accomplished product, and you guys should be proud of it. Now, let me ask a tough question. How many options are there, and what does the base unit with the options cost?
Well, it is a modular system, so there's not a lot of options, but there certainly are a lot of possible ways you could put it together. There is one mainframe. The mainframe is a 4-slot mainframe, so you can put up to 4 power modules in it. The mainframe itself costs $6,500. There are 21 different modules to choose from at different power levels, at different price points, and different performance levels. Those modules range from $500 each to about $3,500 each. So if you blend all that together, a minimum configuration is about $7,000. A full-blown configuration is about $25,000. Typical configuration about $11,000.
Bob, is there anything else you'd like to say in closing our presentation?
Well, I'd like to thank you for the opportunity to share this product with you. Agilent is very proud of the DC Power Analyzer. It's certainly making its way into many new application areas. You know, an engineer wakes up in the morning and doesn't think about you know, what he's going to do to solve his power problems. But when they see a product like this, really the light bulbs go off and they say, you know, wow, I had never realized it's so easy to get my job done. I think a great quote we got from a customer after seeing this product is, you know, now that I've seen this thing, I could get done in 5 minutes what used to take me 2 days. And that's what we mean by really the productivity, increasing the productivity of an R&D engineer.
Indeed, it's a very unique product and very impressive. We've had our technical support engineers take their test using it as a demonstration of their knowledge for DC power measurement. So it's a very nice instrument. And I want to thank you for your time. And I want to thank all those listening, all those engineers and students out there learning electronics. Keep innovating. We need your contributions. Thank you for listening.